Hi guys. So today we are going to start looking at the area of a sector or a section of a circle. So the previous lesson we were looking at arc length. So we were talking about the length of part of the arc versus the length of the entire circle around. So this time we're doing something similar because last week we talked about area and circumference, or the week before that, I can't keep my week straights anymore. So we're going to move on from circumference to area, but this time we're going to talk about part of the area versus the whole area. And the way that you are going to do this, it all depends on this angle right here. So let's think about this. So don't worry about the radius for this purpose of just kind of thinking about this. So if you have a 50-degree angle, you have this area covered. If you have a 210-degree angle, you have all of this area covered. So the larger your angle, the more area it's going to cover. For instance, the smaller the angle, the smaller the area it's going to cover. All right, so we're going to use the same type of proportion because the amount of area covered depends on the angle created. So we are going to start with the angle, or the central angle. So we're going to create our proportion. So it's going to be the central angle out of, remember we're doing part, so it's part over whole. So the central angle out of 360 is equal to part of the area, which we are going to call the sector today, over the whole area. Okay? So now, just like when we were solving for arc length, you had to do the whole circumference. So we've plugged in the formula for circumference. Here, for the whole area, we've got to plug in the formula for area, which is pi r squared. And I know that depending on the video, sometimes I do r squared times pi. The order of that doesn't matter. It just kind of depends on what you're doing, what comes first. All right, so you're going to plug in all of your little pieces. So you're going to have this for this problem. It would be the central angle would be 50. So we're going to go ahead and do this problem. I didn't realize I wrote so big. So we're going to do this problem over here. So it'll be 50 out of 360 equals the part. We want the area of this sector, so we're going to leave that x. Over the area is going to be pi times the radius times the radius. So it's going to be 3.14 times 6 times 6. And then you're going to multiply across, or not across, cross multiply. My bad. Cross multiply. I always want to call it across. Sorry, I know I'm writing really small. I apologize. All right, so you're going to do 50 times 3.14 times 6 times 6. You get 3, right color. So you get x times 360 is 360x equals 5,652. 5,652. And then to solve for x, you're going to divide by 360. So x equals, divide by 360, is 15.7. And we're talking about yards here, so square yards or yards squared. Okay, because remember it's not a singular distance. When we're talking about arc length, it was one line, which is one-dimensional. Area is two-dimensional, so you need that little squared there. So 15.7 yards squared. So if you found the area of the entire circle, it would be much greater than that, okay? All right, so we are actually only going to do 1, 2, and 3 together. Then I'm going to have you do the rest of them 4 through 9. And for this worksheet right here, we are not going to have a forms that you have to click and go plug your answers into. We are I'm just going to give you the answers, and since this is the first time around, I think you kind of have to do this so you learn how to do it, and then your next assignments, there'll be links for you to go fill in your answers. All right, so we are going to do 1, 2, and 3 together, and then after this video, I will post a PDF of the answer key of this. Hopefully you actually do it all and figure it out and make sure you understand, because the other assignments are the ones that are going to be graded, so I really need you to use this for practice. It's just like class. You don't get absolutely everything graded most of the time. Our first assignments is just practice, and then when we start doing the independent practices and stuff like that, that's when you get your grades. So you just have to do it to learn it. All right, so I'm gonna end up doing my work on an extra sheet of paper just because there's not a whole lot of room here to do your proportions. All right, so for number 1, I'm sorry. All right, so you need we're gonna use our proportion again, your central arc length, or golly, I can't read or speak today. All right, so you need your central angle, which is this big angle. So it's going to be 210 out of the whole thing. Remember, it's part over whole. Out of the whole thing would be 360 degrees. And if you want to put your degrees there so you just kind of remember what you're doing, you can. Equals, we need the part of the area, which is what we're solving for, out of the whole area. And the whole area of the circle is pi times the radius, which is 12, times the radius again. And all you do, as long as you have your proportion correct, all you do is cross multiply, divide, and you're good to go. All right, let's see. So x times 360 is 360x. 210 times all those numbers. Let's see. So, sorry. 210 times 3.14 times 12 times 12. You get, sorry, God, this stuff's in my way, 94,953.6. Okay, don't round anything while you're working. Wait till you're completely done to round. Okay, then to solve for x, you're going to divide by 360. And your directions here, which some of you are killing me on your rounding, it says to round to 2 decimal places. So we're going to take this number and we are going to divide by 360. And you get 263.76. So 263.76. We don't have to round this number because it is round. It's to the nearest 2 decimal places. It's the hundredths place. We're done. We only round it if it's longer. All right, so, and we got to look at what we're talking about here. It's inches, it's square inches. So this whole area, this whole gray part is 263.76 square inches. Okay. You have a much, for 2 reasons here, or you have a bigger number. Your radius is bigger when you're talking about the number wise, and then you're covering a large space. If you found the area of this whole thing, then it would be bigger than this number. If you found the area of half of it, it should be less. All right, so let's go ahead and do number 2. We're going to do number 2 with the proportion, and then I'm going to explain. You could kind of do number 2 a different way as well. All right, so for number 2, we're going to use our same proportion. So we need let's remind you of this. So you're going to need your central angle out of 360 equals the part of the area out of the whole area. So it's the same thing. Part over whole equals part over whole. All right, so we're on number 2. All right, so 90 degrees out of 360 degrees is equal to x. We don't know the section of the area over the whole area would be 6 times, my bad. You can do 6 first if you want, but it'd be 3.14 times 6 times 6 pi times the radius squared. Okay, so you are going to multiply 90 in these numbers, 360 in x. So you get 360x equals 90 times 3.14 times 6 equals, what is that, 10,173.6. Divide by 360 on both sides to get x by itself. So you have x. And once again, you don't have to round on this one. Equals 28.26 square yards, or yards squared. So this is your answer, 28.26 square yards. All right. There is another way you could do this, because you know that 90 degrees is a quarter or 1/4 of the circle. So this area has to be a fourth of the whole thing. So what you could do is take the whole area, which would be 3.14 times 6 times 6, and you could divide that by 4 because we need 1/4 of it, and you get the same answer. So because we know 90 is a fourth of that, you could do that. It is totally up to you. Okay, and last but not least, we are going to do number 3. So we're going to use the same exact proportion. Part of the central angle, or the central angle, so part of the angle, so 240 degrees, out of the whole 360 degrees, because remember, the bigger the angle, the more of the circle it covers. The smaller the angle, the less of the circle it covers, equals what part of the area over the whole area. So 3.14 times the radius, 19 times the radius again. Okay, and then you are going to cross multiply. X times 360 is 360x. 240 times all those numbers. So 240 times 3.14 times 19 times 19. I get 272,049.6 divided by 360. Okay, good. You have to round on this one. Okay, so here we go. Those of you that do not know how to round, that are killing me on your rounding, trust me, I do not feel safe sending you to high school in Algebra 2 with you not being able to round. So if you're rounding to the hundredths place or to 2 decimal places, you look at the number that you're rounding to. So 69 is to the hundredths place. However, you can't just cut it off. You have to round it, you have to look behind it. Are we rounding this number up, or are we keeping it the same? So what I would like you to do is write down your number plus the number behind it. So it'd be 755.69 is to the hundredths place, but I want you to write the number behind it. As those of you that have been sending you messages on Remind or emailing you about your rounding, I'm not counting off for it, but it is driving me crazy. I really need y'all to round correctly. All right, so you're trying to see, does 3 round 69 up to 70, or does it keep it at 69? So you only round up if it's 5 to 9. So 5, 6, 7, 8, or 9. This is 3, so it keeps it the same. So x is about 755.69. And what are we talking about? Feet squared, or square feet. So 755.69 feet squared. Okay, so I really think this is going to be pretty easy for you guys, especially if you thought that finding arc length was easy. Then this is pretty much the same exact proportion, except instead of filling in circumference and finding part of the circumference, you're finding part of the area. Part over whole equals part over whole. All right, remember, if you have any questions at all, something on my website isn't working, or you got a different rounded answer, or Miss Warfel, I'm lost, I don't get it at all, please, 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 please let me know via Remind, email. You can message me on Teams. I'm not exactly sure another way you could get in contact with me, but those ways, please, please, please let me know, and I would love to help you. I hope you're all doing well. I hope you're all understanding this and not feeling overwhelmed. If anything comes up, let me know. I hope you all have great days, great weeks. I miss you all. Have a good day.